Tom Paquet. I'm a design engineer here at New England Wire Technologies. We receive all kinds of questions during the design process, and today I'm going to answer some of those for you. What kind of cable performance requirements do you typically see for robotics applications? We see all kinds of requirements. Robotics is not just motors, it's signal, it's data. At this point, robots have become more and more complex, performing more and more tasks, so we could basically see anything. It also comes down to what sort of environment it's going to be living in, whether it's a medical application, industrial application. These are all important things for us to consider. Can you explain the difference in the flexing movements required for robotics? So robots move in very dynamic and complex ways, but generally they boil down to three main types of motion. The first one is just bending, very traditional. Then there's torsional, which is rotational. And then we also see in like C-track applications, you might see something that we call like rolling. So that would look like this. And so pretty much all motions are made up of those three types of motion. So what is the difference between flexibility and flex life? Flexibility is how easily a cable moves, how flat it lies on a surface, how limp or dead it is. It's basically how the cable feels. All of these things are a trade-off in a robotics application though. All of those things that contribute to your flexibility are also things that can eventually sabotage your cable in the long run. So all that flexibility comes from micro movements within your cable between the conductors and in the insulation systems. And those can result in stress points and eventually failures, or they can cause friction and abrasion, which will also result in failures. Flex life, on the other hand, is generally given in terms of cycles. So how many times can you bend something back and forth? So that motion, the back and forth motion, is called a cycle. Most cables last, a few hundred or maybe a few thousand cycles, depending on how rigorous the application. For robotics, this is really, really critical that we be able to last hundreds of thousands or even millions of cycles. So it's a real fine balance that we need to meet between this flexibility and the flex life. What are the special material considerations for good flex life cables? So this is kind of a two-part answer. The first one is conductor, the second one is insulation system. From a conductor standpoint, we're pretty much always going to be looking at alloys. Alloys are harder than copper. This provides a big advantage because they're less likely to deform plastically. Not to dive into metallurgy 101 too much, but all materials deform elastically and then plastically. So if you bend something and it returns to its original shape, that's an elastic deformation. If you bend it and then it keeps its new shape, that's a plastic deformation. Basically, that's just damage to the cable at this point. So we're looking to avoid that. So alloys offer a nice hard material that are less likely to produce these defects. So the second part of that question is the insulation system. And so what this boils down to is choosing plastics that are going to last a really long time. Like with the conductors, these plastics, they need to be resistant to this plastic deformation. So we tend to choose very hard plastics. Primary insulations would be things like fluoropolymers or polyester, and we would use an outer insulation system, which is generally a urethane, because it provides excellent abrasion resistance, and it also tends to hold all of those inner components nice and tightly together. Why is cable design and layout so important? So like we talked about earlier, there are a lot of different types of components that can be put in these cables. Obviously there's power, there's data, signal. All these different components generally aren't the same size and shape, and so it's important how you put those things together to ensure that they last as long as possible. Power singles tend to be a lot larger and so more robust. The smaller data pairs tend to be a little more fragile, and so it's important that we work to fortify those and put them in low stress positions. Generally, part of fortifying a cable is making it larger. So if including a cable into your design is like the last thing that you come to the table with, it's important to remember to leave a lot of space, because the larger this cable is, the longer we can make it last. Does Newt provide testing for robotics cables? We do. We offer a battery of testing. We offer bending endurance, torsional stress testing, rolling torsional testing, and we're always willing to work with customers to develop new testing. And testing for robotics cables is very important because it can give you like real life data to corroborate that this cable is going to perform the way that you hope it does. Are aesthetics important for robotics cables? Aesthetics are always important for cables, especially when the customer gets to see the cable, so any sort of exposed cable. And in the medical industry, this might look like a nice, glossy, light-colored cable, very easy to clean, People always want to be able to see that something is clean in the medical industry, so the cable should represent that as well. If you're dealing with something that might be a little more like for kids, you might want something that's a little more vibrant, a little more colorful, and we have all sorts of color matching on site, so we can give you pretty much anything you want. If you've got any more questions, anything that I didn't touch on or talk about today, feel free to reach out to us at newenglandwire.com.